welcome and thanks for deciding to spend your lunch together with me and Ernesto. The webinar today will be on the semantic layer, which we think is the missing piece in analytics, and is hosted by me and Ernesto. So before we get sort of rolling, some introductory slides are mandatory. So about me, I'm Max Krog. I'm a data/analytics engineer who has been in both sort of technical and analytical roles during the past 6 years. So I've been doing both data engineering, analytics engineering, and also like data analysis and analytics. I've previously been in data roles at Arelion, Transfer Galaxy, and SVT Play. For those of you who don't know, it's the Swedish television company. Currently, I'm doing analytics at Podme, which is a Nordic podcasting company. And I've held sort of previous webinars on a topic that is very similar to what we will be discussing today. So if you find the content interesting, there is more to be had. It is all in Swedish, unfortunately, for those of you who don't speak Swedish. That said, over to you, Ernesto.
Okay, thanks a million. So I'm Ernesto Ongaro. I'm a solutions architect for DBT Labs, and I cover the Nordics. I'm based in Ireland, but I grew up in America and originally from Argentina. My colleagues call me the modern dad to stack because I'm both a dad, I guess, at home, but I seem to be a dad somehow in the office, helping everybody get set up with their pension system. So I got this nickname, and yeah, I've actually been working kind of within vendors most of my career. Earlier in my career, I programmed phone systems and then started working for a BI company called Jaspersoft that had sort of a semantic, two semantic layers actually. One was with traditional OLAP cubes, something called Mondrian OLAP. So I was programming that about 11, 12 years ago. And then there was something called Jaspersoft Domains, which is some sort of a semantic layer that wrote queries for you. And then I spent about 4 years at Google or Looker writing LookML code, and now the last 2.5 years with DBT, and I'm excited to talk a little bit about our work with semantic layers.
So before we get on with it, I also want to say a couple of words about my employer, Signific, which are the ones making it possible for me to host this webinar. At Signific, we help companies learn faster than their competitors by democratizing their data. We're a group of senior consultants with experience from top tech companies across the Nordics. Today's agenda looks like this. I'll be first sort of introducing us to the area of analytics on a super high level, like what do we want analytics to do for our company. Then I'll talk about how we actually do analytics today and some of the challenges that come from how we are currently doing it. Then we segue over to the solution, the semantic layer, and I talk a bit about how that works before Ernesto does a demo of it in practice so you can see how it actually works. We wrap up with some of the benefits of implementing a semantic layer and also some thoughts about what is needed to succeed with the semantic layer implementation. Okay, so first part, what do we want analytics to do for our company? There's many different ways to put this, but one way I like to think about it is the following. Like, we want analytics to make our company more informed, so we all know what's going on. We want it to make our company more aligned, like we all steer towards the same goal and have the same context. We want it to make us more efficient, so efficient in our processes and with our time, but also effective. Like, we care about the actual effect of initiatives, like the results they generate. To sort of summarize, it should make us smarter. Like, we as a company are able to make better decisions. So how does analytics help us achieve this? One way to put it is that it helps us achieve this by making our outputs and outcomes visible. And I assume that outputs and outcomes is a term that's known to many of you and that you've heard the terms before. But for those of you who haven't, sort of outputs are the things that we do, like the activities and initiatives that we control, and we often get a quick response. We get an immediate response on the outputs. Outcomes, on the other hand, is sort of what we achieve, like usually described as the business value generated by an initiative. This is not within our direct control, and we don't get the response right away. Like we have to wait a couple of days, weeks, or months before we see what the outcome was from some activity or initiative. And what we want to do is we want to create a feedback loop between the outputs and the outcomes so that we can understand what should we do more of and what should we do less of. So how does analytics then make these outputs and outcomes visible? It does that by quantifying them into metrics. So pretty much or almost everything a company does today can be measured. Like everything we do within product or finance or support, marketing, sales can be quantified and looked at through a lens of like metrics. And to allow us to look at the metrics more closely, they can be segmented by different dimensions. And both metrics and dimensions are very company specific, but here's an example of some like common dimension categories. Like time is maybe the most common dimension. We want to know when something happened. Customer dimensions, order dimensions, session dimensions, if you're working with understanding how people interact with your web or app. And maybe if you're a content company, you want to slice the content usage metrics on sort of different content related dimensions. So to sort of summarize what analytics is about, analytics is the craft of translating outputs and outcomes into relevant metrics and dimensions. So how do we actually do this in practice? To even be able to do analytics, you first of all need like a data stack. And this all starts with your data warehouse, which is commonly built on top of databases like Snowflake, BigQuery, Redshift, Databricks. And we want to ingest data from the systems that drive our business to this data warehouse. And commonly we get this data from databases, APIs, or by like emitting events and different things happen. So we load this data into our warehouse and we load it as it is into the data warehouse. But the problem is that this raw data that's like has the same format as it does in the source system. It's not very easy to use for analytical purposes. So to make it simpler or to make it like analytics ready, simpler to use for analytical purposes, we usually transform it into a format that's easier to consume for analytical purposes. And in this webinar, I'll just be referring to that as like modeled data. Modeled data means that the data is in a format that is easy to use for analytical purposes. And this transformation of the raw data into this modeled data format is super commonly today done with a tool called dbt. When it comes to how you should model your data to a format that's easy to use for analytics, that's a super big topic that I unfortunately won't really have time to cover today. But if you want to learn more, like feel free to reach out. I've done some previous webinars on the topic, and there's also like a ton of resources online for how to do this. But so then, like assuming you have this well-modeled analytics ready data, what usually happens is that you connect your BI tool to this data to make it available for the wider company. You usually build sort of dashboards that allow business users, colleagues, stakeholders to self-serve analytics. But the BI tool is not the only way to analyze the data in your warehouse. A lot of like data serving is done in other ways, such as through ad hoc queries. And there are also many other ways to like do analytics on top of the data in your warehouse. Like for example, you could use a notebook or data-driven application, something like that. But for the sake of simplicity in this webinar, I'm just sticking to BI tools and ad hoc queries as two examples of how we actually sort of make the data available to the wider business or wider company. So this is all just a sort of stack. It doesn't really create any value in itself. In order to turn the data into value for our colleagues and to help them understand their like outputs and outcomes, we usually try to we help them understand or answer the questions they might have. So how do we usually fulfill requests from our colleagues? So let's assume we get this request from a stakeholder. Like, what was the conversion rate for trials that started in the previous month by traffic source? This is actually a pretty good request, a pretty simple request that's well suited to answering with analytics, as as everyone who works in the field on a day-to-day basis know, like as anyone who works in the field on a day-to-day basis knows, this is not usually the type of questions we get. We usually have to help our stakeholders sort of rephrase the requests into something that can be quantified. So why is this a good request? I would say it's a pretty good and simple request because the metrics and dimensions are clearly defined. So the metric in this request is the conversion rate for trials, and the dimensions are the previous month and the traffic source. So what happens in our heads? What's the sort of internal monologue when we want to help them answer this question? First of all, or the first step is usually, at least for me, and I think for many others, that you think like, do we have a dashboard that answers this question? Or is there a dashboard that answers a sort of similar question that we could maybe extend to also answer this question? If that's not the case, then we have to dig into actually defining the metrics and dimensions. So the first metric here, the conversion rate for trials, we start thinking like, so what is included in trials? How do we handle coupons, vouchers, or like should we only look at the standard product trial that maybe we offer? How should we do if we want to compute this metric over, like, did we not have that trial, the same trial offering in the previous month as we do today? And also, what do we mean when we say conversion? Like, is it enough that they have done some meaningful activity in our product? Should they have converted to the first payment? Should they have, I don't know, reached out to our sales department? Like, it's not super standard, or it's not super explicit what we actually mean with the conversion. The same goes for the traffic source dimension or breakdown. Like, maybe we have no domain knowledge into what is a traffic source. So we're wondering, like, did someone decide what the traffic source dimension is already? And like, did they maybe document it somewhere? And if so, where is that documentation? So the point I want to make with this slide is that even for quite simple and well-formulated questions, such as this one, it forces us to have to make a lot of extra, or a lot of small decisions about how to implement the metric and dimension. So the craft of analytics involves making a huge amount of like mini decisions about the implementation of metrics and dimensions. This is what we do most of the day in my world, or in my view. But the question then becomes sort of, where do we store these decisions that we make? The proper way to do this, the proper way to sort of store the decisions, is like, assuming you have a data warehouse and a modern BI tool, maybe something like Looker. You first create or modify a view in your data warehouse. You connect it to a data source in the BI tool, which basically just fetches data then from that view in the data warehouse. And you define your metrics and dimensions on top of the data source. So this is where you do the storing of the decisions you made earlier. And then you can reuse this data source in multiple dashboards or graphs within the tool. And if you want to answer a question about maybe another part of the company, another process, you have to set up another data source from scratch and sort of repeat the process within the BI tool. So this was the sort of best and ideal case. Most of the times, I don't think that's what actually ends up happening. Most of the time, what ends up happening is sort of this. Maybe for one request, we ended up storing the metric definition directly in a graph in a dashboard. For another request, maybe the stakeholder wanted the metric segmented by some new dimension. So we implemented it right into the ad hoc query that we ran to retrieve this data for the stakeholders. Or maybe it's stored in this other dashboard or data source or graph in a dashboard. Or maybe we have a metric that requires us to add some new field in the modeled data to be able to actually then create that metric in the dashboard. So we store it sort of in the transformation step and also in the dashboard. So to summarize, there's a lot of places where these decisions can be stored, like somewhere in these areas. And here I'm making this sort of simplified view. I'm only looking at BI tool and ad hoc queries here. You probably have even more tools that are interacting with the data in your data warehouse. So more places to store these decisions. To summarize or to point out some of the problems with how we work with analytics today. One problem is that we use dashboards as the answer to everything. It's sort of the best medium we have today. But what stakeholders want is not always a dashboard, or not commonly a dashboard even, I would say. Sometimes they just want the metrics right into an Excel sheet. And we're forcing them to sort of have to go to this dashboard, download the data, and import it into Excel. Another problem is around sort of reinvention and inconsistency. So we have to implement this metric in many different places. So it's hard to know if someone else has created the same metric before. And if we change the definition of a metric, we don't know all the places that we should update it in, but because we don't really have a way to keep track of where is this metric defined. It could be so many different places. And this is something that leads to inconsistencies. Stakeholders interacting with maybe the same metric, but getting different numbers because they fetch the data from different places. And please note that this applies even in like the proper way to do it. That's, I think, the best way we have of doing it today. But even then you would have metrics being implemented in multiple places. Metrics and dimensions are also sort of hard to find and use. A colleague has to go through a vast number of dashboards to see if any of them contain a metric that's relevant for their use case. And if they find the graph they like, but would maybe like to tweak it a little bit, instead of showing this metric over time, let's show it over some other dimension or some rolling sum of it. This is not a straightforward thing to do. The metrics are quite hard to use, and it's simple to make mistakes because they're so tied to the place they are defined in. And another challenge that is maybe a bit more technical, but it is that the modeled data in our warehouse gets a lot of external and unknown dependencies. So if we have a table in our warehouse that we want to like update the name of that column, that's a hard thing to do because there could be so many dashboards or ad hoc queries that depend on how that column is named. So we just leave it with the same name. So this is not good. There's a lot of challenges with how we do this today. How would we like it to be? Like if we could dream, then we would like our metrics and dimensions to be, first of all, consistent. Like they should be the same regardless of where we query them from or where we use them. They should also be sort of reusable. We should be able to define them once and reuse in all these different tools that we use for data consumption. And they should be simple to find and use. Like our colleagues should be able to easily find all the metrics that we offer. And it should be impossible for them to use the metric in the wrong way. So that's a bit about like how we do analytics today and the challenges that come from that. So now I'm going to start introducing the solution to these problems, which is the semantic layer. And I'll talk through a bit about how it works, and then I'll hand over to Ernesto to do a demo so you can see it in practice. So that's coming up shortly. So what is a semantic layer? On sort of a high level, a semantic layer is a component that sits between your data warehouse and all downstream data consumers. It describes the semantics of your data and acts as a single source of truth that all data consumers can retrieve data from. And that was in general about the semantic layer. But DBT Labs has their own implementation of a semantic layer. And to start using that implementation, or to start using DBT Labs' implementation, the first step is to describe your data according to their specification. And this specification consists of two objects. First object is something called semantic models. A semantic model is something you use to describe the semantics of a DBT model. And a DBT model is basically just a table or view in your data warehouse. And with the semantic model, you can describe like which entities, measures, and dimensions exist in this table. And also how the table or semantic model relates to other semantic models. So to illustrate how this works in practice, consider that you have a semantic model that will describe a table in your warehouse. The first thing you should do with a semantic model is define what is the entity in this table. And in this example, the entity is an order. So meaning that this table in our warehouse has one row per order. You should also define the dimensions that are connected to that entity. And in this example, a dimension here is the order state. So this is also a column in the table, which we say that you can use this to break down the orders. And they should also define the measures, like the things that can be counted. So order ID and order revenue in this case. So you create one of these semantic models per table in your warehouse. Here I've added another example where maybe you have a table with one row for every customer. And then you can also define how do these tables relate to each other. So in this example here, we say that every order has a link to one customer. So for every order, there's also a customer. And here is how you link between these two different tables. And so from this, we can sort of start to describe all the tables in our data warehouse and how they connect together. So we build something that can be called like a semantic graph, where we both describe the tables, but also how they join together. And for those of you who are familiar with dimensional modeling and star schemas, like these semantics models are very similar to fact and dimension tables. Describing the semantics of your data according to this to DBT specification actually sort of requires that your data is modeled with some dimensional modeling approach. So that was the first part of the specification, the semantic models part, which we use to then describe the semantics of the data in our data warehouse. The second object of the specification are metrics, which we use to define our metrics. And these are defined on top of the measures from the semantic models that I just explained. So metrics are defined on top of the semantic graph, as I just said. As to illustrate or to make an example, so we could define a metric called orders, which we define as just basically count how many unique order IDs there are in this table, but do it where the order state is not cancelled. So here, I hope this gives you an idea of like how we can use this metric definition to store the decisions we made about the metric. Like you can imagine how simple it is for someone to forget that, okay, we should not count cancelled orders when we count how many orders we have. Same sort of goes for order revenue, just the sum over the order revenue in this table. You could also define a metric that is revenue per order. So yes, we just link back to the previously defined metrics, saying the revenue per order is just the revenue metric divided by the orders metric. And something that will be shown in Ernesto's demo of the semantic layer is that when we want to use one of these metrics, for example, we could use the revenue per order metric. The semantic layer will automatically figure out that this is a metric that can be sliced by the order state or the country, because these dimensions belong to entities that we calculate the metric from. I think this will make sense when Ernesto shows it, how it works in the tool. So how do you use a semantic layer? Hopefully now you understood on a high level how we use the semantic layer to describe the data we have. And just before I hand over to Ernesto, I wanted to sort of show how it works from an architectural point of view. So how applications interact with the DBT semantic layer. So first, assume you have your model data. You have described the semantics of this data. In order to make this accessible to the rest of the world, you need something called a semantic layer API. And this is something that DBT hosts for you. So while the specification is like open source, the semantic layer API is proprietary and you need DBT Cloud to use it. So what happens then is that any application, BI tool or Google Sheets maybe, can send requests to the semantic layer API. The semantic layer API will then take that request, and with the help of the semantics, where you have like described how what your modeled data looks like, it can compile a SQL query and send that to your data warehouse. The data returned from the query is then forwarded via the semantic layer API back to the application that requested the data.
So yeah, thanks for that intro, Max. So in case you haven't heard of DBT, we are a standard for data transformations. So we represent the T in ELT and have extended into some other SL. I guess it's the T and the SL in ELTSL for semantic layer. So yeah, we're extremely popular in the Nordics. I think it's one of the most active regions for DBT from a community perspective, from a adoption and use perspective. It's been an incredible region for us. So I'll go to the next slide and just introduce a little bit about our viewpoint. There's two things that we wanted to do in the market. We wanted to allow self-service, and we wanted to do it in a governed way. So if you've used self-service analytics in the past, in an ungoverned way, that might be in the form of a tool that just lets you write SQL against your database. The problems with that, I think Max has already touched on them. It creates a bit of chaos. Everybody shows up to a conference room with their own numbers, and then effectively the person with the highest title wins versus the person with the correct answers. And then you get into data fights versus anything useful. And then the other side would be the governance, but without the self-service. This is more of an authoritarian kind of style. Hey, only the data person brings the numbers and nobody else is allowed to run them. And these are the official numbers. And so when building DBT, we thought, look, we want self-service and governance. And in order to achieve that, we said, look, you have to do it in code, mostly in SQL code where you define transformation logic. That means it's like the lowest common denominator of a language for anybody in data. You know, we could have chosen, let's do it in Spark, which means, okay, we can do it in Scala, Java, SQL, etc. That means it's less accessible in a way. More options is kind of less accessible because if I do it in Python, then I can't really read what somebody else did. And then the other thing is the governance. Okay, well, if we're going to allow people to author their own pipelines, how do we like add the governance? And we said, well, why do we have to reinvent governance whenever software engineering has been doing it for a long time by using testing, version control, reusability, and documentation? And so that's the DBT viewpoint. There's a famous blog post from like 2016 where Tristan Handy kind of like laid down our viewpoint. We started as a small consultancy company called Fishtown Analytics. There was never an aim to create a product company. So this command line utility that one of the consultants wrote called DBT and called it DBT so that he could type it into the command line very quickly, like cat or all of the kind of command line utilities that are just short names so you could just type them real quick. So anyway, it started there, and this is where it is today. We turned it into a whole thing, including metrics, which we're talking about today, but metadata framework, development, testing, CI, cataloging, orchestration. Like DBT has kind of grown into a lot of areas. And yeah, the one I'll talk about today is metrics everywhere, but just know that there's a whole lot behind DBT, not just semantic layer. So what are you going to see today? What I have in store is I'm going to show you something called DBT Explorer. That's going to show us like, what are the metrics that I have available to me? And how do I look at the actual definitions? How do I trace back to where they came from and trust them? And then I'm going to show you Steep, a beautiful Swedish-made metrics first BI tool, Google Sheets, and then a custom integration with our API. And the idea will be that I will query all three of these live, and we're going to see if my metric matches in them or not. So what you see here is DBT Cloud Explorer. If you're using DBT, this is very similar to the documentation part. If you do a DBT docs generate, you get, it compiles all of your models and things like that, and you get documentation about them. So if I click into models, that's the traditional DBT models. And if I click into semantic models, Max has already introduced what those are. Those are like a layer on top of like physical DBT models. And finally, I have like a catalog of my metrics. So these are the 9 metrics that effectively publishing, and I will be able to show you in these other tools. The one I'm going to focus on is total profit, which is a derived metric, which is total profit for the business. So when I click on that and I click on full screen, it sort of gives me like a lineage view of how total profit is calculated. We can see that there's a fact order items. So order items goes down into the grain that I need for expenses. And I guess it prefers to use the roll up from fact orders for the actual revenue. And I have some semantic models in the middle. This means that if somebody is curious about like, okay, where does this total revenue come from? Where does this orders come from? Where does fact orders come from? They can actually click into any of these definitions and go down to both the table level lineage, but also down to the column level lineage. If they want to see like the where is my, okay, gross item sales amount. If I click on that, I can see that it's called gross item sales amount here, and then it flows through. Like before that, it comes from a field called L underscore extended price. And if I'm familiar with like my CRM or ERP system, then I'll say, okay, so we're using the extended price. That's the correct one. And I build some trust in those metrics. And so I'm going to take some of those metrics and we're going to explore them. I am going to zoom over to Steep. And I didn't mean to have that open yet. So all I had to do in Steep, it's actually super simple. I went to a data source. I configured a data source called DBT Cloud. It imported the definition for 9 metrics. It's kind of live. I can hit sync, and if there's been any change to them, they get brought over and resynced. And then I've been able to actually categorize them into both finance and customer metrics. So if I click finance and I click on total profit, which is the one that we're going to be using, it actually has cached it because I used it just a few minutes ago. And I get effectively the total profit per the last 30 days. If I would like to do any kind of breakdown, this is where all the other semantic models will be shown. And I have things like nation or region, and it's going to group by and show those here. I'm just interested in total profit, and I'm just interested in February 13. So the number there is 470214. The integration is pretty slick. It even allows me to hit about, and it will show the SQL query which was executed. It lets me do a lot of cool things, compare other metrics and things like that. I have to say, from a BI tool perspective or metrics explorer, this is like the easiest I've ever seen. It focuses around metrics and it's pretty easy. So anyway, February 13th, 470, 214. Now let's say that I'm in finance and I want to see that exact same metric in a different tool. I've installed the Semantic Layer extension for Google Sheets. So there's a simple process that you do. You then authenticate to DBT Cloud. And then I've built my query here. I pre-built it, but effectively, you have the 9 metrics, which are live connected to my DBT Cloud instance. I have total profit. I've chosen my options. And then I'm going to effectively have to choose like where I want those to be inserted. And I'm going to run the query. This is where I say a small prayer to make sure that everything will work correctly. But what's happening in the background is we're querying DBT Cloud. DBT Cloud says, the joins that you need is this, and this. It then sends it off to my database, which in my case, I'm using Snowflake, and it comes back. So the 13th of February, we have 470,214 in profit, which is matching exactly what we had in Steep. So that's how that integration works. The third integration I want to show today is it's a Streamlit app. So you're welcome to use this app or fork it. Look at the code in GitHub. It's a colleague of mine, Doug, who made it in the States. This allows you to both explore the metrics that are available, but also query them. And again, I want to spare you the time to like put it together, but I'm saying, look, I want to see it by total profit, metric time, grain for the last 30 days. Same kind of query that I did in both Steep and Sheets. And what's interesting here, because this is more of a demo tool than a BI tool, it's definitely not a BI tool. This lets you see the API request, just to give you an idea that like if you wanted to build your own integration into something like some custom metrics or something in an app or some internal application, it's not crazy hard. Like there's if you know GraphQL, this is a GraphQL API that shows me like, show me the metrics that are available. And then the payload that I'm doing is basically the selections that I've made there. It's like metrics, name, total profit, group by, etc. If you prefer, you can use a JDBC driver that we publish, which is like a weird select star from, and then you do this like semantic layer query. Give me profit by metric, order by metric time, limit 30. And if that's not enough, you could do it just in a straight up Python SDK. So anyway, lots of options for querying them. And of course, I will submit the query, which will compile the query. And let's just look at the data And if we look at the 13th, 470,214. So I matched all three. Beautiful. That is very difficult to do when you have a complex query like total profit. So if you recall, total profit is coming from, it requires a join, it requires a calculation. It is a difficult thing to achieve if you want to have multiple tools that are being queried from the same hymn sheet. So that's pretty much what I have for my demo. I will say that the DBT documentation will talk about our available integrations. So you can see all of the integrations that we have. We have Tableau, Google Sheets, Clipfolio, Steep. This is an interesting one, Push.ai, which is using an LLM to answer your questions instead of a traditional tool. So I guess if I connected that one, I would have to say, what was my profit for February 13? And hopefully I would get 470,000. If you want to learn more, because I think Max and I are talking at a fairly high level in this webinar, we do have a course, the Semantic Layer course, and I'll paste that into the chat in a little while. It's about 2.5 hours, which will like set up semantic models, metrics, and querying from a tool of your choice.
Thank you, Ernesto. I think seeing is believing. I really understood it at first when I saw this type of demo, just seeing it across various tools, seeing that the metrics exactly match, and also seeing how simple it is to understand what metrics are actually available and how can I break this metric down. Like, it's so many challenges that are just sort of removed.
Yeah.
So thank you for the demo. We have a few slides left just with the wrap up before we walk into the Q&A section. So the benefits of a semantic layer are, well, some of them are at least that, first of all, it's fully adaptable to your own data. Like, you don't have to fit your data into one size fits all sort of model. The marketing we see online with this platform where like, bring your data into this platform and it will be available to everyone. Well, the cost of that is usually that you also have to sort of force your data into that model. You don't have to do that with a semantic layer. The other benefit is that it allows us to implement these semantics once and then reuse the definitions downstream. Just what we talked about and what Ernesto showed. It makes metrics super easy to find and use. Like, it's super simple for a colleague or a stakeholder to find the full catalog of metrics. And when they have decided on a metric they want to use, like, they're only able to use it in the proper way. They can't break it down by a dimension that will sort of make the metric error out in any sort of way. And also, as for like a data team working on the data warehouse, like, it creates a clear divider between the internals of your data platform or data warehouse, which is the tables and the column names, etc., and the external interfaces, which then more becomes, so here's the metrics and here are the dimensions. Not here's a table and it currently looks like this, but we might change it. Like, the rest of the business, it's interested in the metrics, and it helps create this clear divider. So what is needed to succeed with an implementation of a semantic layer? There are some problems that the semantic layer from a technical perspective does not solve. Like, anyone who's tried to get multiple departments to agree on a single metric definition knows that this is a bit harder than you think. The semantic layer is only really the technical solution for how do we implement this? How do we get the benefits of having one definition so we can implement it in one place and not have to reinvent the wheel all the time? But you still have to get towards this sort of common agreement on what are the metrics we want to use and how are they defined. But I'll leave you with 3 things you can start getting in place right away if this is something you want to aim for. First of all, semantic layer is a solution built on top of sort of modern cloud-based data stacks. So if you aren't in the cloud yet, you have a lot to gain from making a move in that direction. And I think you have a lot to gain from making a move in that direction, like, regardless of whether you're aiming for a semantic layer implementation or not. But it's a prerequisite. You should also have a properly modeled sort of analytics ready data. So that semantic layer requires properly modeled data, analytics ready data. As I mentioned before, sort of think dimensional modeling and star schemas. And this is also something like where it's like, regardless of whether you're aiming for a semantic layer implementation or not, this will probably help you make your data easier to consume for analytical purposes. So this is probably something you should and maybe are already striving for anyway. And then comes the area of sort of definitions and ownership of metrics. So you probably already know your core set of metrics, but do you have them clearly defined? Do you have maybe an owner for every metric? And if not, then this is something you can start doing without the technical solution of a semantic layer, just getting these definitions in place and buy-in. So then when it comes to time where you can do the technical solution, like that will be the smoothest thing ever, and you unlock a lot of value. That's it for the webinar. So thank you so much for listening in. If you want to learn more about to transition to a metrics first approach to analytics, my colleague Valdemar will be hosting a webinar together with Johan from the BI tool Steep that Ernesto demoed earlier. And they will talk about how they democratize metrics at the company once upon. Over to Q&A.
Matthias asks, can you show a little bit about how data is transformed from a data store such as GCP Firestore or Azure Cosmos? So I'm familiar with Firestore from my time at Google, and I know Cosmos is sort of like a MongoDB document type database. So these tend to be like transaction systems. And so dbt generally works more in like the OLAP world. And so generally speaking, like if we're talking about Firestore, then you would be replicating that data to BigQuery as the first step. And then within BigQuery, we would help you like unnest the, like, because you have a lot of entity attribute value type data where you have to like do a lot of unnesting. If you want to see a concrete example, actually, Firestore and GA4 share the same schema, and we have a GA4 package of dbt, which you can like kind of have a look at how that looks. Let me just add that into the chat then.
Okay, I'll pick the next question to answer. There is one around business logic. Like, is it in breakdown you basically can build questions that allow flexibility for the one exploring? I guess this breakdown gets longer after time.
I think it's actually Steep. It's a very specific question for Steep. So I think the best way would be that you register for the webinar with Johan, but the short answer is yes. Breakdown will show all of the dimensions. So the metrics are like facts in a way. And breakdown, you get a drop down of the dimensions that you want. So if I had only selected the metric profit and I broke it down by day, but I could, in addition to that, break it down by geography or whatever fields are available to that. And so, yeah, this is where you kind of have to go back and do some modeling of the data if you want it to show up in the Explore screen.
And another one that I know I have my take on, but it would be interesting to hear yours as well, Ernesto. But that is, how does the semantic layer work with LLMs? Asked by Lovisa. And well, it's not my take, but I know I read there is a paper that's shown that if you connect an LLM to a semantic layer, so you connect it to information about the metrics and dimensions that you can sort of describe your company with, then it's able to help you, what do you say, way better than if it was just interacting with the underlying tables, like because it understands the semantics of the data. So if you want to build sort of these conversational interfaces where people can just ask questions about your data in a conversational sort of language, then having a semantic layer is what seems to be like enabling that to happen. Would you like to add anything to that, Ernesto?
Yeah, I mean, I think exactly what you said. I mean, if somebody comes up to me and says, hey, what were the sales last week? I would have to say, what do you mean by sales? And what do you mean by last week? And if an LLM doesn't have those assumptions, then it's probably going to hallucinate some of that. And it might find sales from the wrong table or whatever. And so this is like a way that you can encode the understanding. Maybe there's a way to tell an LLM like, hey, if anybody ever asks for sales, make sure you do this and make sure that you take the discount code from this other table and multiply it by 3 and divide by 4. And maybe you can teach it that way. And then you have an LLM with a semantic layer on top of it. But yeah, we have some integrations already. Push.ai. I have a company that I work with in Finland, Recordly, who this week like just did a little demo of their own LLM. Even the Streamlit app that I showed has a little LLM integration from our semantic layer, and so you can see it and play with it. It's open source. I'll put that URL in the chat.
There was a question around row level security as well, like how it addresses that. And I believe, like, since the dbt cloud is what's talking to your actual data warehouse, be it BigQuery or Snowflake, I don't think that would be supported yet, but it also wouldn't be the end user that's interacting directly with Snowflake. It would be through dbt cloud, so the end user couldn't access the wrong rows. So and you can also, like the semantic layer, when it reports data back, I think you can only do it by sort of the metrics and dimensions that you've defined. So an end user can't really see what does the underlying rows look like.
And so, yeah, this is an area where the dbt cloud semantic layer is still in development from a authentication point of view right now. More or less like you're using a service user, but we're working on the ability to effectively tie it to your user so that we can do column and row level security on top of that. So it's a great question. If you're going to be using the current implementation, you need to think about the fact that it's using a service account today. There's some specific questions about dbt core. So hey, Stefan, good to see you after, I think it was 2019 where we met before, but good to see you again. So yeah, the API is part of dbt cloud. Now there is a project called Metric Flow. It doesn't have a semantic layer. It just allows you to do the definitions. And so it's still kind of missing that API piece. And so, yeah, you're right. Like you would need to, at a minimum, like compile your code in dbt cloud and have like one user license in dbt cloud, and then you would be able to use the semantic layer. So yeah, reach out if you want to like do a trial, or you can sign up for a trial account on dbt.com.
So thank you all for joining. I hope you learned something new. Thanks for sharing the lunch with us.
Thank you, Max.
Thank you, Ernesto.